Now that we have our files, let's move on to our inputs. Our inputs are located under the Inputs tab as part of the circuit card. The inputs are fed from the files that we read in earlier as part of the ODB++ archive, and all of that raw data then goes into our inputs. One such input is our parts list, which you can open by double-clicking on, and this will display the parts list here on the right. The parts list contains all of the parts and components that make up our circuit card here. If I double click on one of these parts, it'll open the properties for that particular part. And you can see here that the part number and the part description have been read in from our pick and place file, the component top.odb. And you can verify that by the value that's in here, which is the name of the file that it's referencing, as well as the color, which also references the source and shows you that it's a pick and place file. Based off those inputs, Sherlock is able to use its intelligence to make some predictions as to some of the other fields that may not have been populated or didn't have the information coming in the pick and place file. So for instance, the part type here, Sherlock has intelligently guessed that it's a capacitor, and that's most likely due to the fact that the part description has the term cap in it. So Sherlock's looked at that and determined that it's a capacitor. If I go down to the package tab here, you'll see that all this package data, so my part dimensions, have also been populated. This time this information has come from the package database or the package manager, which we went through earlier. Sherlock was able to pull from the part description that this is a 1210 package, and based off that information, the package database was able to fill in all of the other information regarding our package. If I click this button on the right here with the 3 dots, you'll see that even though the pick and place file did have a value for package length, once verified with the package database, that value was different, and so Sherlock went ahead and used the package database value, as that is more likely to be accurate of a 1210 package. You can see on the left here, there are many other tabs that Sherlock has, and all of this information is tracked, whether it come in from the pick and place file or it's populated from a database such as the package database. We even track properties such as thermal properties and electrical properties, as well as test properties, as you can see here, properties that Sherlock itself may not use as a board level reliability tool, but nonetheless, we have that information, so it'd be a waste to use it. All of that information is maintained within Sherlock. Another source of information that I can use to populate my parts list and make sure that all of my inputs are correct is the parts library. I can do that by going up to parts here and updating my parts from part library. This window will pop up, which will give me many different options for part library, whether it be a local part library or a shared part library that sits on my machine or within my organization, all the way to a global part library, which is the part library that DFR Solution hosts and maintains and adds to as we come across new parts and new packages. Any user of Sherlock, if they're connected to the internet, can query this global part library, as I'm about to do now. Once you hit Update Parts List from Part Library, Sherlock will then look into that global part library and match any information that it has from the parts in my part list to the part library and update that information accordingly. And as you can see here, once it's done that, it will give me a prompt and tell me that it's successfully updated 221 parts in this parts list. So it's been able to update all of my parts here. And you can also verify that very quickly by looking at the color. Now it's shaded in green, which shows that the source is the part library. To go with that part library, any user of Sherlock can always send us a list, whether it be an Excel or some other format, of all of the parts that they use, and we will actually create an individual library for that user or for that organization, send it back to you so you actually have control of your own Sherlock part library on site. Once this is read in, we can assume the information is correct to the part library, but it still may not be correct to the board that we're using or the component that we're using. So I always say, check and verify before you actually trust all of the information in here. Like if I double click on this part again, you'll see a lot of this information now has been populated from the part library, but maybe something is not correct here. Even though it came from the part library, maybe I have a particular part where the package thickness is different than that value that is given in the part library. What I can do is select Edit Part at the bottom of this window here, and I can go through and actually change this to a value that I know. If I've measured the part and I know that the thickness is 2.5 and not 0.6, I can manually change that value in there. If I hit Save, Sherlock will detect that this part actually exists multiple times on my board, and so it'll ask me if I want to save it just to this individual part that I'm editing or all the parts that are like this part, so that share the same part number. If I hit Save, it'll just change it for this part because I only selected, and you can see now the color has changed to being user, and so it's now, the value now is taken from the user. If I click on the button on the right, you'll see that the other values are still maintained there, however the user value has taken precedence. If ever you're filling out information on the parts property window here and are unsure of what to put in that field or what that field represents, on the left there are all of these little question marks which you can always click on. So if I'm not sure what package thickness is, this little window will pop up and tell me what package thickness is, and also give me a diagram so I know what that field corresponds to. And that exists for every field that we have here in Sherlock, in the Sherlock part list. Once I close my part, if I've ever updated anything, make sure I hit Update Layers. That will update it in the database, and that value now is maintained in there, as you can see here, 2.5. Now let's say I've changed it, and I've changed multiple parts, and I want to go back to my original input because I've realized I've made a mistake. That can very easily be accomplished in Sherlock. If I click, select all of my parts and delete them. This will delete all of the parts from my part list, and I can start fresh again by simply going back to my two pick and place files, right-clicking on them, edit properties, hit save, and Sherlock will go through, read and pass them again. So once I've done that, Sherlock will read in all of my parts again. Their original source will go back in as well, and if I want, I can then go back and update my parts list from part library to end up with all of that information from the part library that I wanted. Once I've got all these parts here, I can always export them if I wish. You can do that anytime in Sherlock you see a table by right-clicking, going to Export List, in this case Export Parts List, and here I can select all the columns which contain all of the information on those parts. If I select all these columns, I can export them as an Excel file or as a CSV file, and then use that CSV file or that Excel file elsewhere, or send that to somebody else. Sherlock is very agnostic about its input and output, and so we want to make sure that as much information as is read and is passed on as possible without any data loss, and it is also passed on in a format that anyone can open.